IndigoBlue, in a flask, you mix 2-nitrobenzaldehyde, which is a light yellow solid, with propanone, a colorless liquid. Then you slowly add another colorless liquid with a dropping funnel. This liquid is an aqueous solution of sodium hydroxide. When you add the first drops of the liquid, the dye of the mixture gradually becomes darker. You don't have to stir, for in the liquid the molecules and the ions are moving very quickly because of temperature. That's what we call thermal motion. The chemical species then come into contact. During these shocks, some chemical bonds between atoms are broken and others are created. Crystals of indigo blue gradually appear and aggregates are progressively formed. To speed up this chemical transformation, you can heat the mixture. The high temperature increases the number of shocks, and so you get indigo blue more quickly. You heat for a few minutes and then you cool the mixture. Then you add cold water to create more solid, because indigo blue is very slightly soluble in cold water. In order to isolate indigo blue, you use a Buchner filtration setup. When you draw the air through the water pump, the liquid flows more quickly. Then you wash the crystals on the cold water to remove the impurities that are soluble in the water. You wipe the solid with a buffer. Then you dry it to remove any residual water. You first start the drying process with very absorbing filter paper. Then you go on drying it in an oven heated to a temperature of 100 Celsius degrees. Indigo blue is purified by recrystallization. You can control its purity with different physical chemical analyses. To make paint, the crystals are dispersed in a binder, for instance acrylic, before being homogeneously blended with a mortar and pestle. You can now apply the paint on the canvas with a brush. If you like laboratory sciences, if you're keen on physics and chemistry, then choose the STL-SPCL section, in order to learn sciences in a different way.